Hey everybody, today I'm teaching by candlelight and I want to tell you about a new shape called a hyperbola. So a hyperbola is this curve, this pair of curves shown in blue, and it's got a unique definition. It is the set of all points such that the difference of distances away from two pink points here called foci or foci, focus points, is constant. Let me show you what that means. Suppose we took a point somewhere around here and we measured how close it is to each of those focus points. Maybe it's, I don't know, 15 units away from this focus and 5 units away from that focus. If you subtract those, notice the difference is 10. Suppose we picked a different point, say one further out like this. Maybe that one is 19 units away from this focus. It would be 9 units away from this focus. That difference is always constant. It doesn't have to be 10, but it's going to be some number. In fact, it's going to be the distance between these two focus points. Anyway, lots of other vocabulary I want to tell you about a little bit. First of all, the line that goes through the two focus points is a line of symmetry. It's called the transverse axis. And the transverse axis is going to intersect the curve in two different places. Those two places are called vertices. And so in this case, it looks like it crosses at 4, 0 and negative 4, 0. Those are its vertices. The center of the hyperbola today will always be at 0, 0, but that could easily be shifted like we've seen before. And it's going to always be the midpoint of the focus points. And so if you know the focus points, you can find the center by taking their average. It's also the midpoint of the vertices. So if you know the vertices, the closest points, you can find the midpoint that way too. The hyperbola always has two different curves, although we're usually only interested in one at a time. Those two curves are called branches. Also, something unique about this shape compared to any of the other conic sections we've learned, if you go out far enough, these curves really start to straighten out. And so the hyperbola is a shape that has two asymptotes. And so in this case, those two asymptotes look like this. The further out you go, the straighter a line this gets. Finding and drawing in those asymptotes is a really helpful way to draw in a pretty accurate hyperbola. Hyperbolas can be oriented in two different directions. So you can have a horizontal hyperbola like we have here, or you can have a vertically oriented hyperbola. And so it has two different equations. They're both kind of the same shape. X squared minus y squared equals 1 is a horizontal. Y squared minus x squared equals 1 is a vertical oriented one. And then underneath those, you can put some numbers that adjust where the asymptotes are, where the focus points are, where the vertices are, and so forth. So the vertices are always the points that are either A steps left and right, or B steps up and down from the center. And so that's a pretty easy point to see. Be careful because this number is usually something like 144, and you need to realize that that's a squared, and so 12 might be the actual distance you go out left or right. The asymptotes are very helpful to find, and the asymptotes are always going to have a slope that is b squared over a squared. Sorry, I said that completely wrong. The slope is always b over a. That's essentially rise over run. And so you look at these numbers, and whatever b and a are, that's the slopes of your asymptotes. In this case, these look like they have slopes of 1. So it's probably just x squared over 1 and y squared over 1. This is where I was talking about earlier, the focus length. If you want to find the focal length, you need the formula a squared plus b squared equals c squared. If you watch the ellipse video, that's a little different. The ellipse is a squared minus b squared. So If we want to find that focal length, we'll have to look at a squared and b squared and add them together, and that's the focal length squared. So let's see some examples. Suppose we wanted to draw an accurate picture of the hyperbola x squared over 9 minus y squared over 16 equals 1. Also, we want to figure out where the focus points are. We'd also like to have the asymptotes because that really is a way of drawing things accurately. So the process that I would recommend for this sort of thing is a couple steps. First of all, find the center. Then find where the vertices are by looking underneath that first fraction. And then I recommend you draw a box. That box will help you draw in the asymptotes. And once you've got the box, the asymptotes, the vertices all drawn in, then you can draw in a hyperbola and it'll be really accurate. And then if you need to, find the focus points by figuring out what the focal length is. So let's do that. For this, the center is simply 0, 0. And so the next thing I would look at is underneath x squared. This is a 9. And so that's the vertice length squared. If we take its square root, that would be 3. And so this particular hyperbola has vertices on the x-axis at 3 and at -3. So now what I would suggest we do is draw a box. And to do that, I need to know how tall this box needs to be. It's going to have edges left and right at 3 and -3, but I'm not sure how tall to make it. And to do that, we're going to look underneath y squared. Y squared is 16, and so if we take the square root of that, that's 4. That means this box that I want to draw, I want to go up 4 and down 4 from here, from the center. And so let me draw in a little box here. Again, that's 3 units plus 3 units wide. It's 4 units plus 4 units tall. And so that box is not really part of the graph, but it's going to help us draw the asymptotes. So now the asymptotes, I'm going to connect these corners and go right through the center with some straight lines. So that might look something like this. Once I've got the asymptotes drawn in there, I don't really need the box and these points. And so it might be nice to get rid of them. Now I'd like to draw in the curve. And so that hyperbola, this one's a horizontally oriented one. I know that because the x is first. And so what that means is it's going to come in along this asymptote. At some point it's going to touch this point. That's the closest we'll ever get to the center. And then it's going to go back out along this asymptote. And so that might look something like this. On the other side, same thing. Come in along this asymptote, just barely touch the vertice there, and then go back out along that asymptote. So there's a really accurate drawing of the hyperbola, and we're almost done, except for they also asked us to find the focus points. And so in order to find the focus points, I need the focal length formula. And so the focal length formula is a squared plus b squared equals c squared. So in this case, a squared is 9 and b squared is 16. And so if I add those together, the focal length is c squared equals 25. Taking the square root of both sides, we get that the focal length is 5. And so now if I wanted to find and put points at the focus points, the foci, we would go out 5 from the center. And so there'd be a focus right here at 5, 0, and there'd be another focus at -5, 0. So, one more example. In this case, the equation doesn't quite look right because it's not something squared minus something squared equals 1. It's got this 100 in here. And so what we need to do is to divide everything by 100. Scale that back down so that it is a 1. If we divide both sides by 100, over here the fraction 4 1/100ths reduces to 1 over 25. Here the fraction reduces to 1, and this by design on purpose reduces to 1. And so that gives us a graphable equation, y squared over 25 minus x squared over 1 equals 1. First thing I see in this is that this is going to be a vertically oriented hyperbola. The reason I know that is because it's got y squared on there. And so now what I'd like to do is to try to find the vertices. And so the vertices are going to be, if we look at the number underneath this first fraction, that's 25. That's our vertice length squared. And so I'd like to take its square root. That gives me 5. And so, that's not the right color. Let's see if we can make this blue. There we go. Sorry about that. So we'll put that up at 5 and down at 5. So now I'd like to draw a box, and I know that box is going to go up 5 and down 5. How far out, how wide that box is, I look at this number underneath x, and that's 1. 1 squared is, so its square root is 1, and so that means I'm going to go left or right 1 spot. And so that's a really skinny box. Looks something like this, right? 1 unit out, left and right. Now, the box is there so that I can draw my asymptotes. I'm going to connect the corners and extend them, and that'll produce lines that look like this. So here's one asymptote, and here's another asymptote. And at this point, I don't really need that box. Well, it doesn't hurt to leave it in there. Draw it lightly if you're going to draw it in pencil. And now, because it's a vertically oriented parabola, I'm going to come, or hyperbola, excuse me, it's going to come down along this asymptote, just touch the vertex here, and then go back up. And so it might look something like this on top. And similarly on the bottom, it's going to come up along this asymptote, just touch the vertex and turn back around again. And so it'll probably look something like that. Last thing, they didn't specify it in here, but if we wanted to find the focus points, I know they're going to be somewhere vertically oriented, but how high up and above these are they? And so to calculate that, we need to use the equation, focal length equation, a squared plus b squared equals c squared. So that's going to be looking at these numbers. And so that's 25 plus 1 is c squared. That means 26. And if I take the square root of both sides, c is approximately 5.1. And so that means my two focus points are 5.1 units above the center and below the center. So in this case, 5.1 is like just barely inside the hyperbola like that. And negative 5.1 is just barely underneath it like this. So there's a little video on how you can draw hyperbolas and some of the important points. Check back next time to see how we can shift it up and down and left and right so they're not always centered at 0, and also how we can write equations for hyperbolas.